Achieving carbon neutral with eTool. The challenge for architects. In the past 50 years alone, humanity have used more natural resources than was required to sustain us in all previous history. A scary statistic, but one which illustrates how quickly we can implement change. The change now will be one of dramatic improvement in natural resource management, whilst maintaining and improving our lifestyle. This is a reality if we remove waste from the life cycles of our products. But how is this done in the built form? What we were hearing from the industry. I understand the concept of embodied energy, but I can't calculate it, and is it really important? Thermal rating tools are missing the big picture, but all my effort is going into this area. Nobody can tell me, is it better to use a local energy intensive product or an imported energy efficient product? Life cycle analysis is the best practice for sustainable design, but there's no cost-effective software or service to carry it out. I want to build a carbon neutral building, but there's confusion on what this means. Who can actually calculate this? Environmental best practice uses life cycle analysis to assess the relative merits of different design options. The process should account for the true environmental impact from cradle to grave, or better still from cradle to cradle, which is a closed loop of recycling. The embodied energy of a product is made up of the resource extraction, the processing and refining of the raw materials, the manufacturing of the product, the energy input into the product during its life, which is also known as operational energy, and the energy required to recycle the product. Embodied energy calculations also account for the transportation between or during these steps. The principles and methods of life cycle analysis are detailed in international standards. Now let's take a closer look at embodied energy and operational energy. In the built form, the breakdown is approximately 60% operational energy and 40% embodied energy. If we relate this to the total carbon footprint of OECD countries, we see that it's very significant. In fact, it is estimated that buildings account for nearly 40% of total carbon emissions in OECD countries. In Australia, we have recently taken on a rigid approach to measuring and improving thermal performance, which is very encouraging. Unfortunately, however, thermal performance only accounts for about 6% of our total carbon emissions and 15% of carbon emissions from buildings. There is also a large degree of behavioural influence on thermal performance. With the help of eTool, 100% of the carbon emissions of a building can be calculated. The above statistics are supported by CSIRO research. They estimate that 11% of total Australian emissions relate to the embodied energy of residential buildings alone, and 17% of carbon emissions relate to the operational energy of residential buildings. Let's take a look at a case study. We will detail the results of a life cycle analysis for a carbon neutral building. First, we need a starting point or a benchmark from which to work. This represents the base case or normal construction that one might find on a suburban block in Australia. Let's take a closer look. The benchmark has 4 bedrooms and 2 bathrooms. It has a sturdy construction of brick veneer and tile roof. It has been designed for repetitive production. Its average lifespan in Australia is 35 years. In the push for a carbon neutral dwelling, we need to provide an alternative. We increase the density on the same block size. The alternative has 4 dwellings with 3 bedrooms each. The construction is of high quality and a mixture of light frame and high thermal mass material. It has been custom designed for the site. Expected lifespan is higher. In this case, it is bound by the durability of the construction. The benchmark, on the other hand, is bound by the redevelopment potential. It is much harder to redevelop buildings with shared walls and also more expensive whilst ever there are detached houses in the surrounding streets, which make easier targets for purchase. The result is a 3-fold increase in expected lifespan. Bear in mind that this figure is an average for this type of development. Ideally, we should be designing for 500 to 1,000 years. This development currently represents very good practice. The aim should be to match the redevelopment potential with the construction limitations. This way, waste is minimised. Now let's look closely at the makeup of these buildings. Materials are selected for the design process. The new design with shared walls, high lifespan and light frame construction where possible is well under half of the benchmark. We can reduce this even further with the help of eTool by swapping some materials with low embodied energy alternatives, using recycled materials and making small design changes to eliminate components with high carbon intensities. The materials need to be transported to site. In some cases, the transportation energy can be higher than the material energy itself. eTool will calculate these trade-offs for you and highlight areas for improvement. Once again, the new design performs far better than the benchmark. We now consider the assembly energy. The largest energy consumption during assembly is usually the travel of the tradespersons to the site. Using construction methods that have a low labour requirement, are faster to erect or require less heavy machinery, we can reduce emissions significantly. The use of local services also reduces transport emissions. Recurring energy is often overlooked. This is the energy put into the building to maintain it. Although paint is a small portion of the initial embodied energy, over the life of the building it can be very significant due to the high churn rate. Reducing painted surfaces with the use of natural finishes helps combat this and also has ecological benefits. To complete the life cycle analysis, operational energy calculations need to be made. The architectural quality of the new design is critical here. Thermal performance is excellent. A closer look at the breakdown of operational energy shows that thermal load in the new design is nearly reduced to zero. Water heating emissions are minimised with solar gas instantaneous boosted hot water systems. Energy efficient appliances and lighting also help to reduce operational emissions. The net result is a 1.4 tonne reduction in carbon emissions per bedroom. This is pretty impressive, but we can take things even further with eTool. Renewable energy generation is considered next, in this case solar power. Although the panels contain embodied energy, this is well and truly offset by the energy generated, and fed back into the grid it offsets coal or gas-fired electricity. In a grid environment, this is very significant in primary energy and carbon emission terms. Electrical generation using fossil fuels is very inefficient at converting primary or potential energy of the source fuel into delivered energy at the house. When using renewables at the source of the home, emissions, including those embedded in the materials, are nearly zero, and electricity pumped back into the grid offsets a lot of carbon. In fact, in this example, the operational and embodied energy are offset, resulting in a truly carbon neutral home. But what about affordability of carbon neutral dwellings? It's interesting to see, in a life cycle sense, the carbon neutral dwelling is actually more affordable than the benchmark. The initial cost will be more, but due to the lifespan, the total cost to society is less over time. This makes sense. Energy is expensive and will continue to climb in value as resources become scarcer. A lower energy and carbon intensity results in a lower cost. We'd like to acknowledge the designers and developers of this project, Officer Wood's architecture firm and Earthcare, the developer. Although the focus in this example has been on carbon emissions, there are numerous factors contributing to sustainable design. Carbon reduction often results in a positive effect on all of these areas, but not always. In order to ensure that eTool is the best environmental assessment package for the built form, we will be expanding our services moving forward. Please contact us if you'd like more information or a life cycle assessment of your own building. Thank you.